Welcome all to the first unit of the module DC Electrical Circuit Analysis. The first unit is Basic Concepts. Here we discuss about resistance, factors on which the resistance depends, temperature coefficient, Ohm's law, and the most important topic, resistors connection in series and parallel. To begin with, the first topic, resistance. What is resistance? It is an opposition. It is an opposition offered by the substance to the flow of electric current. If we consider the voltage as the source or the power or the energy which gives rise to the flow of electrons, that is the current, resistance can be considered as a force trying to resist the flow of electrons. The unit of resistance is ohm and it is represented by the Greek symbol, and it is often represented by the zigzag line looking like a speed breaker. Based on the value of resistance, materials can be broadly classified into two types, that is, conductors and insulators. Conductors are those materials which offer very little opposition to the flow of electric current. Commonly all the metals like silver, copper, aluminum, etc., they all have very low resistance to the flow of current. Insulators, on the other hand, are supposed to have very high resistance to the flow of current. Example, glass, rubber, wood, etc. Now, coming to the factors upon which the resistance depends. We will start with first the length of a sample. The length of a wire and the resistance is directly proportional. That means if you have a sample of higher length, its resistance is found to be more than a wire of the same material but with a less length. Now the other factor is the area or the size of the sample, and this time the relationship is inversely proportional. That is, if you have a wire of higher area, the resistance is found to be lower, and if you have a smaller area, then the resistance is found to be high. Now, of course, the resistance depends on the nature of the material that we already seen now. Conductors have low resistor, insulators have high resistance. Now here we have a factor called as resistivity or specific resistance as a representation of the nature of the material. Now, the last point, the resistance of any wire, any sample, depends on the temperature as well. Based on these understanding, the resistance of a sample can be calculated by the rule R is equal to rho L over A. Rho represents the resistivity, L represents the length of the sample, and A is the area of cross section. Now, studying little more details about the effects of temperature on resistance, we can see that the resistance of a material of course depends on temperature, but this depends on the type of the material. If you consider some pure samples, that is pure metals, the resistance and the temperature is found to have a linear relationship. That is, if the temperature increases, the resistance of the sample also increases. The temperature resistance graph is supposed to be a straight line for most of the pure metals. That is, they are called to have a positive temperature coefficient of resistance. On the other hand, if you have some insulators or semiconductors, their relationship is opposite. That is, Their resistance decreases with an increase in the temperature. These materials have negative temperature coefficient of resistance. Now, the effect of temperature on mixtures such as alloys, the common example is a steel. Their relationship is it increases with the rise in temperature, but the increase is not steady, it's not regular. So that's the effect of temperature on resistance. So the summary is it depends on the type of the material, and based on this understanding, now the equation for the resistance can be modified a little bit. So the resistance with a temperature dependent can be calculated as it's equal to Rho plus Rho alpha delta T, where alpha is called as the temperature coefficient, delta T represents the rise in the temperature or the change in the temperature, Rho represents the resistance at room temperature, and RT is the new value of resistance at a new temperature. Now materials have positive alpha, negative alpha. Depending on that, the new resistance value may either increase or decrease. If some materials have zero temperature coefficient, that means the resistance remain the same irrespective of the change in temperature. Normally the Rho value is considered to be the resistance at room temperature or particularly at 20 degrees Celsius. So the topic that we discussed so far are what is resistance and the factors, mainly the effect of temperature on resistance. Now we'll discuss our next topic is Ohm's law, followed by the resistor connection in series and parallel.